should have switched spots with you. Okay, you got several open? Okay.
So mine are open in a different browser, so you don't
Okay.
even see them right here. So here's the main UPlan page. Is that what you wanted to get to?
I do.
There you go.
And which browser is that one on?
That is this one right here that's lit up. So it'll be the last browser.
And then we have our slides, right?
We,
So you'll
yeah, I'm
start-
going to open them up right now.
Okay.
But that's not where I wanted to start, so I'm going to go back to the front. Okay, here we go. Okay,
Cool.
Okay.
And then to get to
Escape.
just you can push escape or you can go right up here.
Okay.
This one you're going to have to push escape, okay? So, and then you can go, you just minimize this, and then you bring either one of these up, and there looks like it's, you got a whole bunch of them. And so the home page will be this one down here, okay? Far right, far right, okay?
Okay. We'll be good.
Far right.
All right.
And this, you know, if it just gets too bad where everybody's just struggling, going back and forth,
I'll just be going.
We have
I'll
the-
just be transitioning
Okay.
from the slide right to UPlan.
Right.
And I'll stay in UPlan.
Yeah, and once
Right.
we're in UPlan.
Okay, once
unless
you're in
Andrea,
UPlan.
though, needs slides at the end.
yeah, and I got them, they're in there.
Okay, so she can come back to.
Yeah. Right.
Okay. Okay. Well, let's, Dave, have you guys all take your seats and let's get
All right.
started so we can get going.
I think we're ready to sit down.
It's time, right? It's time. It is time for our session to start. We'd like to welcome everybody out to the Uinta Basin Transportation Study Session. A couple of announcements we will hand out. We'll get one started on each side for the sign-in sheets. That's if you want special credit to work for your continuing education. Okay, today on the Uinta Basin Transportation Study, we have a variety of speakers over here to my left, as you see. I want to introduce each one of them, and then we'll turn it right over and get them started. John Thomas, who's with UDOT. Craig Hancock, also a licensed engineer with UDOT. Dave Nazaire with HDR. I'm Vern Kiesler. I'm over here moderating. Charles Allen are with Interplan. Andrea Mosier with BioWest. And we have Troy at the end with Civco Engineering. So today we're going to talk a little bit about the Uinta Basin Transportation Study, and we're going to turn it over to the project manager, John Thomas.
Okay, get that adjusted. All right. Good afternoon. Can you hear me in the back? A little higher. All right, how's that? Is that better? Okay. Several years ago, there was a lot of interest by the locals in the Uinta Basin for UDOT to assess the transportation needs of the extractive industry out there. And it was really interesting because we didn't know much about what the extractive industry did. Now, Dan had done some work in identifying how many trucks per well it took to drill and operate after oil was being produced. But beyond that, we didn't really understand the market and the industry and how things worked out there. And as we started down this path, one of the things we started to learn was, how did a well get drilled? How many trucks did it take? Where did the material come from? How is it going into and out of the basin? And then once there was production underway, what happened to the trucks in? And we really didn't understand that whole equation. What we started to do is understand how transportation worked out in the basin, and we combined it with what are the economics, because that was the really interesting part in this whole thing. Was as those trucks, those super tankers you see coming from the basin to the refineries here, what we learned was once those trucks get to the refinery, they're paid about 25% less for their oil than they would be for that same oil in refineries in Los Angeles or Houston or in Oklahoma. And that's kind of created this opportunity for us to go, well, what things should we be doing to help that industry perform better? And so we said, okay, well, there's trucks. We get that. We see there's trucks that move in and out of the basin. There's pipelines. And really the only thing that flows in the pipelines is some crude oil from other states and the natural gas that's out there in the basin. We also learned that maybe a train would be a good idea. Would a train create that difference for the producers to make enough money on bringing that oil from the Uinta Basin to Los Angeles, to Houston, to Oklahoma City, where there's a lot farther distance to be traveled, but maybe there's an economic benefit in that. And the economists at HDR interviewed some of the producers out in the basin. They understood the costs, what it took to bring a barrel of oil from the basin to the refineries here in Salt Lake. They understood what it would take to bring a unit train of crude oil from the Uinta Basin to, say, Houston. And there was profit to be made if there was train service available. So UDOT then was asked to start to do corridor analysis. And what we picked up was a 200 by 200 mile square area, study area, encompass parts of Wyoming, Colorado, Utah. And we had to try to figure out if there are any routes for a train to come out of the basin and connect to an existing rail line. And for you folks who understand the basin, it's surrounded by mountains. And so that's kind of why there isn't a train there already. And so we identified 26 possible alternatives. These routes range from 100 miles to 250 miles long. And then we tried to say, well, are any of those feasible to be built? And UDOT has invested a lot of money in some technology and some tools that allowed us to very quickly evaluate those 4,500 miles of alternatives and say, yeah, it looks like we got about 2 alternatives that look pretty good. One of them went up Indian Canyon along 191, shared the roadway, and then punched through Indian Canyon Pass with a 10-mile tunnel and ended up in the Emma Flats area. And what was interesting in all of this is we were able to bring the technology that UDOT and the state has invested in to bear, and we came up with those alternatives within about 2 months and that we knew would work. That was pretty incredible. Normally that would take several years to do, and the money we saved from doing it in 2 months versus several years was pretty dramatic. I think we estimated around $3 million just on that effort. But I think the real savings came in, we didn't spend another 3 or 4 years spending a lot of money, getting a lot of commitment, buy-in on the process, the idea of train service in and out of the basin. We were able to determine right away what that cost was. When that cost was presented to leaders in the basin and at the state, political leaders, and they understood that now a train to come in and out of the basin was going to cost $5 billion, it changed their mind about the value of that train. Now, nobody knew that going in, but because we utilized our tools, our technologies, we were able to quickly say, probably not the right time for a train. What that allowed us to do was then focus more on the roadways. And Craig was leading the roadway study. It was in a parallel effort to the rail study. He was leading the roadway study so that we could better understand how best to serve the extractive industry with roadway type transportation improvements. And Craig spent about a year with his team from HDR and Interplan and BioWest, and they came up with some really, really interesting, innovative ideas that will definitely help the transportation out in that basin, getting to Salt Lake's refineries. And Craig's going to come up and talk in more detail about some of those things that they found here right now. So bottom line was the train was really interesting to understand how it would work. Very challenging to build, very expensive. Maybe sometime in the future it'll come back, but for now the train to the Uinta Basin is on hold. But a lot of other transportation improvements are coming to the basin, and Craig's going to come up and speak to those now. Thank you.
There you go.
So I can already tell I'm going to need to lower this down or get a stool. All right. Can everybody hear me now? Yes, in the back? All right. Thanks. So as John mentioned, we had two parallel projects going on in our Uinta Basin study. The first one was the rail study that John talked about. And then the other part of this study was a road study, and that was the piece that I was involved with. Our part of the study was really to look at the transportation network in the Uinta Basin, and to look at both some of the existing problems that were there, and then to look at looking into the future. We used 2040 as our planning horizon and looked into the future to look at what the transportation needs would be out that far. We had a couple of objectives that we wanted to accomplish with our study. The first objective that we wanted to be able to do was to develop a vision for the Uinta Basin and the transportation system in the Uinta Basin. Oftentimes when we went out and talked with folks out there was often what they had in mind for, say, what US 40 ought to look like was different than what the department thought ought to be the vision for US 40. And so one of the things we wanted to accomplish was to develop a vision for the roadway network. And Dave's going to talk a little bit more about that in a few minutes. Another objective that we had with the study was to develop a little bit of local collaboration with the folks out in the basin. Often when we were looking for projects to build in the basin, do I need to adjust that? Okay. All right. There we go. When we were looking for projects in the Uinta Basin, a lot of times what we would do is we'd go out and ask them, hey, where's the next passing lane? Where should the next passing lane go? Or where should we put the next intersection improvement? And the feedback that we got from the Uinta Basin was really great. It was a good place to start. What our study did was we looked at it from a data perspective. We got a lot of data, we did a lot of analysis, and then we married up, so to speak, the data with the input that we were getting from the basin. And so we felt like at a region level, as we were putting forward projects to design and build, that we were putting together the right projects and we were putting them out at the right time. One other objective that we had with the project was we wanted to develop a unique way to deliver this study. We knew we were going to be using U-Plan. We had a lot of analysis that we wanted to show on maps, and we were looking for a good way to package all of that and produce that study. And so we used our U-Plan technology and platform to develop that study. And John and Andrea and the team were huge in helping us get to that point. So what we're going to do is we're going to do most of our presentation today, presenting most of the data from our study, and it's accessible to anybody. And so I'm going to attempt to try to direct you to where the study is found. If you're familiar with U-Plan, you're already halfway there, or more than halfway there. But if you're not familiar with U-Plan, if you simply type in your Google search U-Plan, UDOT, one of the first entries you'll get is the link to this webpage, and you can quickly navigate to the UPlan webpage. From there, what we've done is each of the regions have an area where they keep all their maps, and they're called galleries. And in our region, if you click on the Region 3 gallery, it'll pull up our set of maps, and within this area is our UPlan, or is our Unibasin study. So it's located right here at the bottom in the middle, and I'll go ahead and open that up as well. You can clap for me too. It actually came up. Yay! Okay, so this is actually our study, and it's done in the UPlan environment. It looks somewhat like a typical study would look like. We're at the home page, and we think of our home page like the executive summary. So we have a number of maps, and these maps represent some of the results that we got from the study. On the side over here, we have our table of contents, and you can drill into the sections of the study by clicking on the links. It'll take you into the section about safety or the section about operations and so forth. We've found this to be a great way to present the data because so much of it was developed in this type of environment. And you'll see a little bit of this functionality as we talk through our study today. One last thing I wanted to bring up was to briefly talk to you if you're not familiar with the Uinta Basin, the area that we're talking about, and kind of the scope of the project. If this will pull up for me. It'll go. Oh yeah, okay, good. I really like the map that's found in this one handout here. Okay. So when we talk about the Uinta Basin, what we're talking primarily about are the counties of Uinta County and Duchesne County, and somewhat into the Wasatch County. And the routes highlighted in green in this map represent the routes that we studied in our study. Some of the key routes were US 40. This is the major east-west corridor through the Uinta Basin. If you talk to the folks who live in the basin, they really look at US 40 as the I-15 of the basin. It really is their link to the Wasatch Front. We also looked at some of our major north-south corridors as well. We looked at US 1 or SR 191, the section that goes from Vernal up to Daggett County into Flaming Gorge area, and the section of 191 more on the west side of the basin from Duchesne down to Carbon County and connects to US 6. And we looked at several internal routes as well. Another nice feature of this study is we also incorporated some of the local roads as well, since they also obviously interact with the state system as well. So we looked at, so one of the major routes that we looked at was Seep Ridge Road, an extension of that, and we did a feasibility study that would extend that road down into Grand County. That was done as part of our study at the request of the county. So that kind of in general gives you a sense of the scope of this study. It was very comprehensive. Some of the aspects that we looked at, the approach that we took was we wanted to look at the study look at the roadways from the standpoint of safety and capacity and operations. And I'm going to turn that over to Charles to talk a little bit more about how we did that.
Thanks, Craig. Craig mentioned the three facets of the state highway analysis: safety, operations, and capacity. And in honor of being in the midst of hunting season and talking about the basin with lots of wilderness and national forest area, I'm going to call it the three-pronged approach to our state highway analysis. So who went hunting about a week and a half ago? Let's see some hands. Oh, Vern, we never heard about his experience. Must have not been good. So, all right, three-pronged approach. I'm going to go back to the main page for the Uinta Basin study. On the sidebar of the study, there's more information about each of these three areas: safety, operations, and capacity. And each one of these, we can click on the link and come to the main analysis page. So here's the main safety analysis page. And I'm going to, once we're here, open up the safety analysis map. And in the interest of time, I've got one opened up already. Uh-oh, let's make sure we can find it. There we go. It's like a cooking show, put in the oven. Here's what it looks like when you're done. For our safety analysis, we examined a bunch of different crash types in order to isolate some of the patterns and hotspots and problems that we can expect to see in the basin with unique characteristics that the basin has. So in this particular map, we can take a look at some of these unique crash types and visualize where some of these hotspots are. For example, passing-related crashes at intersections, passing maneuver-related crashes away from intersections, angle crashes. Each of these might be indicative of a certain type of problem. For example, an angle crash might indicate where we have an issue with a need for turn lanes at a rural intersection. Commercial motor vehicle crashes, pedestrian and bicycle crashes, most of these occurring in some of the urbanized areas. And then finally, the wild animal crashes, which are everywhere. So, Vern, maybe your best shot about getting a deer is to hit one on US 40. So we'll try that next year. With these hotspots identified, we looked at each of them in a little bit more detail. So I'll bring up yet another image here. So here on the safety page again, I can click on safety projects and start to look at some of the hotspots and what we discovered and concluded for each of these locations. So it'll start to load. With each of these hotspots, we took a look at all the crash records in detail, started developing crash diagrams to help us understand if there is some sort of project that can address the issues here. I'm going to go to one of my favorites here in Duchesne at the intersection of US 40 and SR 87. I can click on the number and the crash diagram will appear. Here it is. So probably even a caveman can start to recognize some of the patterns occurring at this intersection. You can see there's just an obvious pattern of right turn vehicles sideswiping another right turn vehicle, this particular intersection. So we thought, what is going on here? This is really interesting. So looking at an aerial view, you can see this southbound approach. There's a left turn lane here, and then there's a really wide lane to accommodate all other movements. And we understand, because of our work and talking with people out there, that there's a lot of truck traffic coming south on 87 that's then making a turn to head on 40, to head out of the basin or to head to US 191. And so our theory was that these big trucks, in order to complete this right turn, are swinging wide, and somebody who doesn't recognize that that the big truck is turning right is sneaking in the gap on the inside, and then they're getting sideswiped. I'm going to open up Google Street View for this area so we can picture the situation a little bit better. Here we go. All right, hopefully nobody saw what I'm trying to show here. But we're here on US 40. I'm going to turn us so we are facing west. All right, here's the intersection right here. There's a signal now, so this picture's a little bit old. But you can see this big tanker right here on 87. I'm going to step us forward a little bit. Raise your hand when you see it. All right, starting to see it? Right there. So I thought this was just a lot of fun that Google captured the exact sort of phenomenon that we thought we were seeing. Here's this person. This truck may be turning right, maybe making a through movement, but this vehicle is snuck in between. So now with this understanding, we could recommend a project to come back to this intersection, do a little bit of restriping, and hopefully make it a little bit clearer when a truck is swinging wide to make a right turn. Our safety analysis did not always result in... Now I've got my stuff stuck, Vern. I don't know how to get out of this guy.
Go up here, you can minimize that, then you can go to
Oh, here we go. Bingo. There we go. Not all of our analysis resulted in an engineering project. Sometimes we noticed that the safety hotspots might require a little bit of coordination with others. There were a lot of bicycle crashes in Vernal, and rather than just recommending, let's just throw in some bike lanes or some signage, let's take a step back and coordinate with the city, with some of the locals, and see what their policy is. Do they want bicycles on US 40, or do they have a preferred network they'd like to get the bicycles onto other roads? Okay, so that's probably enough for safety for now. The second prong to the approach is capacity. Forecasting traffic conditions in the basin is difficult. There's a historic boom and bust cycle, and depending who you ask, you can get a wide range of projections as to how many people and how many jobs will be in the basin in the future. So we utilized some different sources. There's the previous study in the Uinta Basin that forecasted some future populations, as well as the Governor's Office of Management and Budget. On top of that, there is possibility of rail coming to the basin, and that would have a significant impact on travel and on truck traffic. In addition, there are some ideas about expanding the county road network that can impact the way vehicles move. So all this resulted in a broad set of possibilities, 8 futures I like to call it. We put together a matrix of all the different combinations of scenarios and developed a matrix of the 8 futures that the basin might have. Now, rather than analyzing every single one of these in deep detail, we picked the one that resulted in the lowest amount of traffic on roads in general and the one that resulted in the highest amount of traffic, and used those to bracket or frame our discussion about capacity needs in the basin. So with this forecast, we moved on to level service analysis. The basin has, or a study area, which goes all the way to past Heber, has a wide range of road types, 4-lane divided highways, busy arterials with frequent signals in downtown areas, and lots of 2-lane highways. The 2-lane highways provided a unique analysis because they work a little bit differently. Classically, capacity can be thought of with the pipe analogy. Your pipe, you look at the cross-section of the pipe, you see a big circle, it starts filling up with water. As the water gets to the top, you approach the capacity of the pipe. That's how a lot of the roads work. You have a physical capacity of how many cars you can have on the road. And as you get to that capacity, your level of service starts to drop, and you start to have a failing level of service. With 2-lane highways, they're a different animal because your ability to maneuver on the highway is influenced much more by a truck, a hill, getting stuck behind the Winnebago, which is just stuck behind another Winnebago, not being able to pass them. So level service on rural highways is defined by a concept called percent time spent following. So you can, if conditions are right, you can have a very poor level of service even though the pipe is only partially full, maybe about halfway full. So a lot of the level service analysis in the basin revolved around this concept of percent time spent following on 2-lane highways. I'm opening up this application which shows the results of the level service analysis for the basin. And you can come in here and see what are the existing conditions, green, yellow, red maps showing good, fair, and poor level of service, as well as our range of futures, our 2040 lower volume scenario and higher volume scenario. So we can start to understand where we have deficiencies and identify projects that will address these deficiencies and start to time when we should include these projects. Lastly, I'll talk about operations. Our third prong. Our operations analysis focused a lot on passing lanes. Passing lanes make a big impact on 2-lane rural highways. And so we inventoried all the passing lanes on the state highways in the basin and started to screen them for particular metrics, such as are they long enough? There's this interesting legacy of really short passing lanes in the Uinta Basin. Here's just a map of all the passing lanes. Green are ones that are longer than 3/4 of a mile. Red are all the passing lanes shorter than 3/4 of a mile. There's quite a few of them. My very favorite, some of you are probably familiar with this one, here in Fruitland. It's striped about 0.15 miles long, including tapers, it's about 0.4 miles long. So if you sneeze while you're driving, you might miss the passing lane. So there's a lot of opportunity for improvement. Another metric we considered is the interval between passing lanes. This particular map shows, again, in green, all the passing lanes in the basin, and in the red are highway segments where it's greater than 5 miles to the very next passing lane. So with this understanding, we started to identify what are some projects that address some of these passing lane deficiencies and began to identify passing lane projects, projects that make new passing lanes and lengthen existing passing lanes, as well as some signage projects. We've found that those next passing lane signs, 5 miles, 3 miles, are very important. They're very helpful. They help decrease some of the anxiety that you might have when you have no idea when you're going to have a chance to pass the Winnebago or the big tanker. So that's a project that actually got funded, and kind of a funny story when Craig tells this, when they're getting ready to develop the signage plan, okay, how many miles is it to the next passing lane? They were looking at the Fruitland one and deciding, do we really make a sign for this one? Do we really admit that this is a passing lane, or we just skip it and go to the next one? So, fun exercise there. Lastly, there was a lot of overlap we found from these 3 prongs: safety, operations, and capacity. Some of these areas got hit multiple times. Safety analysis said there's a need for passing lane. Capacity analysis says we need some widening within 10 years. And so we started to realize we need a way to plan this out and understand where and when we need to plan and complete projects, which worked towards developing a vision for the highway, which now Dave is going to tell us a little bit more about.
Good enough. Thank you, Charles. Good afternoon, everybody. This project, like all the others we work on, takes twists and turns. And probably one of the most interesting turns it took was at a update meeting for Region 3 leadership, the staff update, where we kept them apprised of our progress, and we got some feedback, and we moved forward from there. We were analyzing all the data that Charles just showed you, and we were coming up with some preliminary projects, some ideas of what these projects might be. And we were showing them to Region 3 leadership, and Terry Newell was in the audience as well, and she brought up the question that just kind of stopped us in our tracks, as only region directors can ask those questions. And she said, these projects look really good, but how do we know that they fit into the vision of what the basin transportation system is going to be? How do we know this passing lane project fits in with the vision for this piece of corridor? And so we all kind of scratched our heads, and we had a pretty good discussion about what she was asking us, and realized, that makes a lot of sense. If you look at the long-range plan in the urban areas where we have MPOs and we really focus on what the future corridors are going to be, we often see, take a 2-lane road to a 5-lane in the future. But when you look at the rural 2-lane roads throughout the state, and you look at the long-range plan, there's often just, in this 30 miles, somewhere have a passing lane of 2 miles or 3 miles. And that's really not a vision for what that corridor is going to be in the future. So the question she was asking was really valid. So we took a step back, and as a team, we went ahead and we began developing the vision for the basin. And this was a very, very interesting exercise. We didn't have a lot of time to do it. We didn't have the opportunity, the budget, or the schedule to have a whole bunch of meetings with the locals. So we just put our heads together and came up with what we determined would be the vision. Now, what we did was we analyzed the data that Charles was just presenting, but we also considered engineering judgment in it. what makes sense. Yeah, the data can take you in a certain direction, but what makes sense for a 2040 vision for all the corridors? We also wanted to include the vision that the locals had, because that was very important. You've probably heard a couple times now, the counties in the Uinta Basin see US 40 as their I-15. It is their major corridor. And they have a vision in the future that it's going to be 5 lanes from Vernal all the way to Heber. Now, we've all heard that a lot, and that's their vision. But what about their vision for other corridors? What about their vision for 191 or 87 or 45? Those are real important. And that's where Troy Osler came in. He was just instrumental in getting us the perspective of the locals into this vision. Really helped us out a lot there. And then finally, as we started looking at, okay, what is the vision in 2040 for all these different sections? What cross-section consistency became a big theme. As we started looking at it, there's certain areas on these 2-lane stretches, and even US 40, where you go over a mile and the cross-section goes from 2 lanes with no shoulders to 2 lanes with some shoulders to 3 lanes. One of that 3rd lane was a left turn lane, and then they go to another 3-lane section, and that 3rd lane's a passing lane or a truck climbing lane, and that all changes in a mile. And for driver expectation, that is very, very confusing. So we also tried to look at keeping the vision, keeping the corridors consistent over long stretches. What I want to do is I'll just focus in on a few, so hopefully you can do this too, right? All of this is available online, like Craig said. You can go in here and play around with it, but I'll just touch on some of the more interesting ones. This is US 40 between Naples and Jensen. And so the way we set up this app, for each segment, you can click on it. We tell you what the vision is that we're recommending. In this case, it's a 2-lane facility with a center turn lane and standard 8-foot shoulder widths. We explain why. What was the rationale behind that? For this instance, right? Charles was telling us, we had thresholds. We wanted a level of service C before we really initiated a project. But there's light enough traffic even into the future that this didn't exceed that. But there's a lot of driveways and turn lanes and side streets on it. And so what we ended up recommending was a 2-lane with a center turn lane for that whole distance. And then we also give a when should the department implement it? And there again, that was pretty much data driven. So in this case, we're saying by 2025. It's also nice, we weren't fiscally constrained, so unlike the long-range plan, we could do whatever we want. That was really fun. But we also, with each of the visions, put in a typical cross-section, and this is the one for what we came up with here. Hopefully it will load quickly, like this. So every section of corridor in there has this with it for the vision. I just wanted to touch on a couple more. Mentioned briefly, we know that the vision for the folks in the basin, and the data supported this by 2040, to have a 5-lane corridor from Duchesne all the way to Vernal. And depending on what segment you are, the timing changes a little bit, but that's pretty much the vision that we're seeing for 2040 for US 40. We also know that the locals really wanted to see the 5-lane go all the way to Heber City. And as we started analyzing the data, we just couldn't justify it. We couldn't come up with a 5-lane that extended that whole distance. What we struck upon, however, was what's called a 2+1 facility. And a 2+1 facility is used quite extensively in Europe, a little bit in Australia. It's been used somewhat in the US, but not very much. And really what it does is, what we're recommending is, from Duchesne to Heber, have a consistent 3-lane section, and the passing lane swaps back and forth from one direction to the other along the way. So the drivers understand that there's a passing lane coming soon, and they can plan on that. This type of facility is also a great transition between what a typical 2-lane rural and what will eventually be a 4-lane facility. So it kind of works as that transition. And our recommendation for the timing of it was do the 2+1 by 2040, but then beyond 2040, you'll probably need the 5-lane section. Of course, listening to what Carlos was saying about autonomous vehicles, by the time 2040 gets here, we may not need this at all, but we had this for the ultimate build out. One last corridor I wanted to just touch on regarding the vision is 191. Hopefully you're seeing what I'm seeing. South from Duchesne. Let me close this. One of the things that we noticed about this corridor and this particular corridor and has been happening lately is the energy producers are finding other markets for their waxy crude. Typically, they was always bring it to Salt Lake, but they were kind of held hostage for price, and by opening up other markets, they were finding they could get better prices for their waxy crude. And one of the ways of doing that was to run the traffic over 191 to the rail transload facilities, which I think there's 3 of them now, in the Wellington area. And that suddenly increased significantly on a percentage basis the truck traffic that was going between Duchesne and Price. And so that was not unnoticed by us. And what we did with our vision for that, I'll show you here, South Rural, basically a 2-lane facility with standard 8-foot shoulder widths. But we also included passing lanes in there in some select locations where we felt we could shoehorn them in. And if we did that, then the level of service C that would be exceeded in 2020 was circumvented. The other thing I did want to point out on our vision is here's the legend. And you can see we've got all the roadways up there on top, 4-lane divided. That's US 40 and Wasatch. 2-lane, 2+1, 2-lane without a center turn lane, 2-lane with it. But we also included the rail project because that was going on at the time. And frankly, that's still a vision for the basin. That hasn't gone away. The economics isn't right now. In the future, it'll most likely be looked at again. And so that is still what we would consider to be in the long-range vision of the corridor. In addition, we included some of the county projects. For the most part on this study, the counties, we just used their transportation plans and got the projects into the application. But they also had some greenfield projects and some other projects that they wanted to see that had some regional significance as far as a vision goes for the basin, and we included those too. Excuse me. Craig mentioned the extension of Seabridge Road down to I-70. Uinta and Duchesne were very interested in Perriette. Troy has been working a whole bunch on this Averill corridor, which is kind of a truck bypass in Vernal, and then of course Heber City has had on the long-range plan now the Heber bypass. So that's all part of that. So with now this basin vision in mind and an understanding of, okay, what do these corridors look like in the future, we were then able to go back, maybe, and work on the projects. Can you get me back, Vern? If I can get to the projects.
You want to get to it?
Yeah, if you can pull up the... even the home page.
Okay.
So with the vision in mind,
That one?
home page.
Okay. There you go.
Nope, that's not it either.
Well, you're out of time.
Homepage. I'm out of time. Okay.
Sorry.
You pulling the hook on me? Okay, so now with the vision in mind, we were able to go back, and I'm back on the home page, and you can see we kind of have 4 chapters here. The first one was the introduction. We touched on it a bit. The second ended up being the vision, because we felt that was so important for moving forward on that. And then from that, we were able to put together the state route project map. And so I'll open that quickly and maybe just touch on one. Why'd you use that finger? Okay, so this is the statewide, what we're calling the state route project phasing map. And I'll go back to that 191 section and just pop it open. Maybe. And here it is. So here's that South Rural. And on this app, we've reproduced the segment vision, but in a more succinct form, so that as the region's using this tool, they can look at it and say, okay, this is what the vision is. And then we put 3 phases of projects on each segment. And they align with the long-range plan. But like I was saying before, we weren't fiscally constrained. We just went with whatever made sense from a timing. Obviously, this doesn't mean they're going to end up on the long-range plan in phase 1. That still has to be figured out. But what we did with these projects was develop them a little bit further. So all the phase 1 projects on this map contain a fact sheet. And what's amazing is we were able to do all this from desktop. And we did it with Google Earth, GIS maps, very, very little on the ground. And I wouldn't call it quite concept level, but it's pretty close. It's pretty close. And what we tried to do with all of these projects is give some background information, an estimated cost, look for some of the impacts, the objective of the project, and then we also gave just a little bit of information there again from the desktop, from using the LiDAR information that planning is now developing. We've even showed that, how the existing is, how the new project will fit into it, and a lot of other data that the region can now pick up and move forward with and develop concept reports, get projects into the long-range plan, wherever they think they need to do with it. So with that, I'll turn it back over to Craig and Andrea, and they'll explain how the region is now using this tool, how it's fit into the long-range plan, and I think the region's even written a sequel to this story.
What do you want to open?
Just back to the home page of you.
Okay, let's see if we can find the homepage real quick. That's right there. Perfect.
So, as Dave mentioned, we're now we've had this study completed now for a little while, and we're starting to utilize it to program projects and move some of the things that we identified in the study and moving that forward. One of the key I thought was one of the key elements of our study, and was the fact that we were able to coordinate with the long range plan. During our study, the department was in the middle of updating the long-range plan, and Andrea was key in that. And so I thought she could talk maybe a few minutes about how we did that.
I think it's right at the end. Just scroll all the way down here. So for this, because the US 40, the Uinta Basin Transportation Plan was so well developed, we were able to take a lot of the needs assessment, the well-defined needs assessment for all of the projects, and essentially integrate those projects that have been defined through this study, along with taking the information relative to the timing and all of the project details that have been specified, and a little bit more detailed cost estimates that were more refined than what we're usually able to produce for the long-range plan. And we were able to just bring that right into the long-range plan. As Dave mentioned before, and also Craig, there is another element to the long-range plan as you're taking these different studies into consideration. And, we had the luxury through the Uinta Basin Transportation Plan to really identify the projects as to when they were needed based on the need, and kind of eliminate the funding from the question. And as it moves to the long-range transportation plan, there's actually the goal for the department to be fiscally constrained like the MPO partners, so that they can produce a unified transportation plan that is fiscally constrained altogether. So with that, we were able to take all those timing considerations and the project details and the more detailed cost estimates, and bring that into conversations with the region about the priorities, so the programming priorities that are decided through the commission prioritization process, all of that information, and move that to a fiscally constrained long-range plan. And then, of course, the region also took that information and identified a lot of projects from the get-go for the STIP in the same manner, those type of considerations in moving ahead. I just wanted to point out, this is just, instead of taking you to the long-range plan webpage, the webpage, it was on this slide. It must have been removed. udot.utah.gov/go/LRP. This map shows you kind of, based on the fiscal constraints, what was able to be moved forward to the long-range plan. So everything shown in yellow is unfunded. Those projects that are in red are phase 1 projects that are happening over the next 10 years, and then 10 years after that, and then the remaining 7 years for 2040, or 6 years for 2040. With that, do you want me to say thank you? Okay. Turn it back over to Craig.
Thanks, Andrea. So some of the things that we're doing with this study, once it was completed, we actually took it out to the locals. We reviewed it with them. We went over the vision map with them. We went over some of the projects with them, and it was very instructive to get their feedback. And we were able to begin to discuss, for example, the vision of US 40, and we were able to work with them, and hopefully we're closer now on what the vision of US 40 ought to be. We're also able now, with some of the fact sheets that were shown, we've been able to begin implementing a lot of the projects that we identified out of the study. The project that Charles highlighted, the intersection in Duchesne, that was kind of a fun one that we knew we had a problem there, and it turned out we also had a micro going on in that same corridor, and we were able to get with the PM and with the RE, and rather than creating a whole new project, we were simply able to, the contractor was simply able to make the changes, and so a very difficult, or an intersection that we saw a lot of accidents has now been fixed and restriped, and it's working better now. So we're starting to see a lot of the benefits that are coming from the study. I just wanted to end with we've started to move in the region beyond this kind of format that we heard today from Carlos a little bit about story maps. We're taking that idea and we've now applied that to the US 40 corridor, and we created using the same data that we came from the study. We actually created a story map for US 40, and I thought I would just play or show you a snippet of that if I can get to it real quick. Okay, let's see. Okay.
Let's go to this one. That's the one you want, right there, homepage?
No, the U-Plan homepage.
You plan homepage, okay.
Sorry. Almost there.
There.
Keep going. There we go. That's it. Okay. One of the things that I learned on US 40 as I was working on this project is how important the basin is to the economy of Utah, and how important the transportation system is that supports supports the economics in the Uinta Basin. And that was a message that we heard loud and clear from many of the locals that were there. And because of that, we wanted to be able to begin to tell that story, not from the data and the study, which sometimes that story gets lost, but we wanted to be able to tell that story in a different way. One of the ways we went to was the corridor and using the story maps. So in our gallery, we have a new app called the US 40 Story. And within that, we start using the same data. We start telling this story. And one of the great things about this is when we put this app together, we actually went out to many of the locals and asked them, and we were able to record that. And so I thought what I would do is just end our presentation on this note, and hopefully you can also gain maybe a great appreciation for the Uinta Basin as well.
US 40 to us is Main Street. That's Main Street, and for any community, Main Street is really the lifeblood of the community.
Highway 40 is a major transportation corridor. It's vital for tourism and the economy.
US 40 is extremely important because it's our major link to the Wasatch Front and even to Denver. With the oil industry being so important here, that's our main outlet for the trucks to haul the oil into the refineries into Salt Lake.
Here, we don't have freeways, and so Highway 40 is really how we get product in and out. It's our main artery road. It really is. It goes right through downtown, obviously, and the main road between really the Wasatch Front and the Heber Valley, all the way to the Uinta Basin. I just want to thank UDOT for your continued efforts in going forth with the study and working with all of the people and the offices that understand the importance of this road.
So hopefully you've been able to gain a little more understanding of our study and why we felt it was an important place to begin to understand, and at least for certainly in our region. Thank you.
Let's give him a round of applause before we end. Questions or comments for our panel? I'll take the microphone over to them. You don't want to hear it from me. Questions? Okay, I'll load one up. Craig or Dave, tell us about why we needed wider shoulders and why we designed wider shoulders for this particular project.
Yeah, unfortunately, because you rushed me along, I didn't get to it, Vern. But I did want to point out on some of those cross sections that, a lot of the vision for the two-lane state routes is just add shoulders to them, just to give give motorists a much more comfortable feeling, give freight a place to pull off. The problem in the past is it's very tough to do just a shoulder widening project, and because on paper it doesn't add capacity, but I think intuitively it kind of does. On US 40, I believe the standard for that is 8-foot shoulders. When we recommend the 5-lane cross section, we're also recommending 10-foot shoulders with that to give freight enough room to move off of the travel way because they will not move onto the dirt. They will not get off the pavement. And if it's only 8 foot, they're going to be hanging in the travel lane. The question was, has the price of oil affected the timing of any of the projects? Is that right? Do you want to?
Well, in the near future, we've programmed out our projects. I'm not sure we've looked at necessarily what the price of oil is doing there. We know that eventually the economy will come back and there'll be the need will always be there. And so we're continuing to program projects in the Uinta Basin and addressing the needs from a safety and capacity standpoint as well.
I work for the Motor Carrier Division, and I was out in Uinta Basin working with Highway Patrol about pulling off and doing inspections, and how they actually have to take a carrier a couple miles sometimes to a safe place so they can do an inspection. So when you're doing these projects, is like Highway Patrol on the, like who's giving all the input? The commissioner? I don't understand.
When as part of our study, we did reach out to the trucking industry. We also obviously reached out to the local commissioners and the local people who live in the area. And so we were able to get a lot of feedback from that group.